Now it's a pleasure for me to continue with the view. Hopefully I get the slides. First of all, I'm very happy that I can introduce you today here our findings on a real sustainable pathway for 1.5 degree Celsius. We already know we are in desperate problems, and as you see, by mid of the century we have to be net negative. And depending on the question how fast we react now, and fast means this year, next year, immediately, the more we can allow to not to go to enormous negative levels, but enormous negative levels means half of the emissions today we have to extract again out of the atmosphere year by year. The cost may come down to the numbers we saw before, but it will be incredibly expensive anyway, so to get to zero emissions as soon as possible is for sure the least cost solution. And what we have noticed is that society changes very fast right now. Maybe this is good, because it seems to be this is the only way to, how to say, secure our civilization. So Greta Thunberg, everyone knows here. But we have it also in Europe that more and more energy ministers or member states of European Union call for fully renewable energy systems to get it fixed. This had been the picture from March 15. The same was last Friday. There were more than 1 million. At that day it was 1.6 million young people all around the world where it was not forbidden, demonstrated that we, this generation here in the room, act now, because we lost the last 3 decades with doing not enough. And this is luckily well supported nowadays by scientists. They're called Scientists for Future. Of course, it's supported by scientists for many decades, but now civil society unites to get the pressure increased to move fast. Now I would like to show you the key results of a latest study just published in the last months. By the way, the study we have dedicated to the Fridays for Future school strikers, because we truly believe they will change the system. Our generation have been not good enough to get it done. Okay, so what we can show is, sorry, it was too fast. What we can show is energy transition is not a question of technical feasibility or economic viability. We just have to decide we want to have it. So it could be not easier from that point of view. The key research I'm doing is on fully sustainable energy system. A fully sustainable energy system is finally a renewable one to avoid other problems. And this has also the positive side effect that most of the energy can be used domestically. In the country where the energy is needed, we can still have international trade for some forms of energy, but in principle will be not needed. Now, what is the key outcome of our research? Is that from today's energy system you see on the left-hand side, which is dominated by fossil fuels, it's coal, oil, gas, we can shift more or less to a fully renewable energy system, which is mainly based on solar and wind. You might be highly surprised by the high share of solar. It's solar photovoltaics, and the reason is the costs are so incredibly low. In almost all regions today in the world, it's the least cost source of electricity we have. And by the way, we all know the results of the IPCC models. They're incredibly wrong in this technology. There's just a paper currently published where you see all the cost assumptions they have. For the year 2050, the cost assumption for solar PV they have in these models are typically twice as high as what is the cost today. And then be not surprised that the outcome tells you it's expensive, the renewables cost a lot of money, but of course if you have the wrong assumptions in models, you have to be very careful with the outcome. So the reality progresses much faster. That is really good. By the way, these results I show you now, the cost we have assumed for the year 2030 is achieved today in Europe and India, so which are among the most competitive markets in the world. However, the other markets are not much higher. So the progress is very fast. The standard progress is minus 20, 15% cost per year. So within 5 years' time, you can imagine the situation is completely different. We did it in a very high resolution. That's important. We have the world structured in 145 regions, so larger countries split in several regions. Everything is in full hourly resolution with real weather years, 1 hourly resolved, how have been really the solar irradiation, the wind per region, and we have more than 100 technologies there. It's for the entire energy system, and I can fully confirm what Jim said before. In the end, we talk on a really broad electrification. And you can see it on the left diagram that our primary energy demand can even go down in the next, let's say, 15 years due to broad electrification. Our thermal power plants, our combustion cars, our combustion-based heating is highly inefficient. If we do it on an electricity basis, we typically can do by a factor of 3 better. And this is the reason why the energy services still go up, the primary energy demand can go down. However, in the, the second half of the next roughly 35 years to 2050, energy demand again goes up. The reason is we are then around 10 billion people in the world, more than 2 billion more than today, and the standards of living are assumed to be higher, and we need more of the so-called power to X processes. That means converting electricity into a form we still need as a final energy form. We may still need chemical fuels for intercontinental marine or aviation interconnections, but that can be produced with electricity. In the end, it's a 100 years old technology. You need low-cost energy, electricity, plus water and air, and then we can produce, for example, jet fuel. It's also called synthetic fuels, e-fuels, power to liquids, more or less all the same. And the consequence is that by 2050, we can have from the primary energy in the world almost all based on electricity, and the reason is very low cost and a high efficient energy system. And now is the question, such scenarios can be done easily. The question is what's about the cost? And this is highly attractive because we find that the energy system cost fully stays stable. Of course, one requires strong capital investments, but of course they are done in the infrastructure for decades. So the annualized cost stays stable to the today's system. What we already heard before, the high share of fuel cost is substituted finally by capital investments, by infrastructure investments. And this is maybe the largest business opportunity in history. What we have there, we talk on, at least our numbers, 67,000 billions of euros of cumulated investments needed for 2050, but the energy system cost stays stable. That's the key message. By the way, the results for the power system had been published March this year in Nature, and this concept of power to X is published this Friday in Science with the leading photovoltaic researchers in the world, where we end up with the numbers are just from this study, with 30,000 to 70,000 gigawatts of PV, which is a factor of 60 to 140 what we have installed today in the world. And this global leading PV researchers, we talk on Fraunhofer in Germany, the NREL in the US, IIST in Japan. It's really the global research hubs. What does it mean for electricity? Electricity means enormous growth, maybe even as we had it 100 years ago when the world had been electrified the first time, but now it's the electrification of the overall energy system, so it means a factor of 5 to 6 growth from all electricity generated today to the future, and then dominated by solar. And one of the key reasons is, so these are all the 145 regions in the world, and by what source of energy, finally electricity, the local energy systems are dominated, and you clearly see the sun belt of the world is dominated by the sun, not so much surprising. In the very high north and in the south, but the equator is here, so the same latitude in the north, we only find mainly water in the south. There we have extremely strong winds, and due to the strong seasonality, wind is very important in the winter half year. And if one cannot really find a dominating source of renewable electricity, then it's colored green. It's then a mix of wind and solar, which is also typically in the northern hemisphere. But solar energy will be the dominating source of energy, and it's the true solar age, which is a sustainable age. Just to highlight the transport sector, because this is one of the harder to mitigate or manage sectors. First of all, from the final energy demand, it's quite amazing that the final energy demand can be stable, while we assume in our model, it's based to international assumptions, the transportation services triple from now to 2050. So we assume a strong interaction in the global world with exchange of goods, exchange of people, so finally travel, air travel, and marine freight transportation. So there is a factor of 3, but you cannot see it in more final energy demand, and the reason is the strong efficiency increase, in particular in the road sector. And the reason is that today's combustion car has a 20% efficiency from the fuels to the wheel. If you compare that to an all-electric car, we talk on 70 to 80% efficiency. So this is a factor of 3, maybe even more, and that we can see there. But in the end, it's the same as we find it for the overall energy system. Fuels are substituted with infrastructure investments. It's again where the energy comes from, solar and wind, but then we need in addition electrolyzers to produce hydrogen, and the hydrogen can be converted, by the way, also with CO2 direct air capture, what we have heard in the very beginning, then to hydrocarbons, what we typically know as jet fuel, diesel, gasoline. So all these kind of fuels can be produced in a synthetic way, but then not anymore with a fossil ingredient. That's the key. What does it mean for the greenhouse gas emissions? So it's a true zero emission system by 2050. And please have in mind, we have modeled the full energy system in a full hourly resolution. There is no hour where is not enough energy available, and for the world in 145 regions. There is no other model in that level of detail so far. The remaining greenhouse gas emissions are around 400, maybe 500 gigatons CO2 equivalent, and this is what we call a 1.5 degrees Celsius scenario with a 66% probability that we are there. What we already heard before, this is not enough. We have to go to 1 degree, so negative emissions by on 2050. But I want to focus here the first step, and the first step is to get rid of our drugs, so we have to be zero emissions. And then when this is achieved, then we have to go to negative emissions. That's then the second step. Of course, the immediate question is, will it cost jobs? What's the situation for the jobs? First of all, and this is only for the power sector in its today's structure, the jobs will go up, but also the energy demand will go up, electricity demand. So all in all, the jobs per generated electricity will be more or less stable. However, most of the jobs will be in the erection of these plants, but then the most in operation and maintenance, not so much in manufacturing. And we are the very first, because we did it in full hourly resolution, to also see there are also several million jobs when it comes to storage. This was typically not regarded before, because the models have been not able to model full hourly resolution, and then you don't find storage. So we also get additional jobs in storage. That's important. Now I would like to summarize the key aspects. So a 1.5 degree scenario with zero emissions in 2050 is possible. It's technically feasible, economically viable, but we have to go for. The specific energy cost shrinks slightly, so let's say it's cost neutral, but our assumptions are conservative. So our cost assumptions for PV for 2030, they are achieved today in India and Europe. So I would assume with the really today's cost and cost projection might be even 10% less. It's a very broad electrification of the entire energy system. From the primary energy point of view, we have 90% electricity in the system, and parts of this electricity is then converted to fuels, to coal, to clean water, to all different forms where we use energy. The energy services expand, so that's not a scenario where we tell the people, and by the way, everyone has now, from now onwards, to take less. We can still have our standards of life, but we have to do it in a much more clever way. That's the point. More renewables leads to more jobs. That's fine. The key technologies, by the way, solar photovoltaics, wind energies, batteries for the cars and for stationary storage, heat pumps in the northern hemisphere and in the very south. Synthetic fuel conversion technologies, there we have several ones, by the way. Having this technology, this is then also the sustainable solution for the global chemical industry. We did it in full hourly resolution, high resolution, geospatial resolution. No risk technologies are required to get to zero. but what we need is political will and ambitious execution, and that we need now. That's it. Many thanks. This is the presentation, energywatchgroup.org. You can find it or contact me via Twitter or email. Many thanks for your attention.